Hello and welcome back to Curiosity Lounge. Before we start, hit that red subscribe button so that you never miss out on any of our videos. Wormholes have fascinated humankind for decades and have even appeared in movies, but locating them has been impossible and the concept remains a theory. However, scientists now have a powerful tool in space, the James Webb Space Telescope. Will this biggest ever telescope finally prove Einstein's wormhole theory? Watch to the end to find out. One of humanity's most outstanding achievements in space is the recent launch of James Webb Space Telescope, JWST for short. It was delayed for decades and severely ran over budget, but that does not distract from the fact that this is a feat of human ingenuity and an insatiable appetite for knowledge. It will help us find answers as to why we are here and how we got here. It will also answer the age-old question of whether we are alone in the universe or if aliens could come knocking one day. The JWST is not the first space telescope to be sent out there, so what makes it unique or different? Well, costing nearly $10 billion, the once-in-a-generation flagship mission is the most expensive ever attempted. However, the cost is not the only extraordinary thing about the JWST, because it's the most technologically daunting project of its kind. Its mind-numbing complexity involves hundreds of mechanisms that must work exactly as planned for the telescope to operate as designed. To fulfill its mission of capturing the faint infrared emissions from the dawn of space and time, the telescope built by Northrop Grumman is cooled by a 5-layer sun shield the size of a tennis court that had to be folded up to fit into the launch vehicle. The complexity continues once in space because the hair-thin layers must be deployed precisely. On the side of the shield facing the sun, temperatures will be a toasty 260 degrees Fahrenheit. On the other side, the optics and instruments will be chilled to as low as 370 degrees below zero, a roughly 600-degree temperature differential. That's equivalent to a sun protection factor, or SPF, of about 1 million. The result is an operating temperature less than 55 degrees above absolute zero, the theoretical point at which atoms freeze in place. As if that cooling is not enough, one of the Webb's 4 science instruments is equipped with its own cooler, allowing it to operate at less than 10 degrees above absolute zero. And then there's the telescope's 21.3-foot wide primary mirror. The largest ever launched, with 6 times the light-gathering power of Hubble, it comprises 18 gold-coated beryllium segments, 6 of which also had to be folded away to either side for launch once in space. Those 2 mirror wings must be rotated into position and locked in place. Then each segment must be individually tipped and tilted as required to achieve a perfect focus. If that doesn't resolve a problem, each segment has a separate motor-driven mechanism that can change its shape ever so slightly if needed. Fully deployed and cooled to the planned operating temperature, the JWST will be sensitive enough to detect, in theory, the heat of a bumblebee at the distance of the moon. It is 100 times more powerful than the old and faithful Hubble telescope. Many people have asked what could go wrong. However, the appropriate question was actually what could not go wrong. Because with all the folding and unfolding parts, the JWST ended up with about 40 deployments, 178 release mechanisms that encompass 9 different designs, 155 motors, over 600 pulley assemblies, and about 1,300 feet of cabling. Out of those 178 release devices, 107 of them are associated with the sun shield alone. But that's not all. The JWST has over 26 miles of harnessing and wire harnesses, 30,000 or so fasteners, and almost 1,600 connectors. You can now begin to appreciate why the telescope costs so much. Do you want to hear the craziest thing about the JWST? Everything has to work precisely as planned or very close to it, or the most expensive telescope in history could become one of NASA's most crushing failures. Unlike the Hubble Space Telescope, which operates in low Earth orbit, where spacewalking shuttle astronauts could correct the focus of its famously flawed mirror, the JWST is parked in place a million miles away, far beyond the reach of any repair crew. Fast forward to today, the JWST launch went smoothly atop an Ariane 5 rocket in French Guiana, and a trip to space was smooth as well. The JWST is now sitting pretty in its orbit in Lagrange Point 2, where it will orbit the Sun. Thanks to its 4 state-of-the-art instruments designed to capture infrared images and spectra, the JWST will extend astronomers' reach several hundred million years closer to the beginning than Hubble has ever done. Studying the first stars and galaxies is not the only scientific program JWST will perform. It was actually conceived as a general-purpose observatory on which astronomers from around the world can apply for time to support their research. For example, observing in infrared will allow JWST to see through the clouds of dust that enshroud very young stars, which are opaque to visible light. Unlike Hubble, it will be able to see right into stellar nurseries where stars and their planetary systems are being born. The observations will answer questions about how the clouds of dust and gas collapse to form stars and how planetary systems form around them. Now to the original topic of the video. When fully operational, do you think the JWST will help scientists uncover the truth about Einstein's wormhole theory? To answer the question, we will look at what wormholes are. Get ready to be amazed. A wormhole is a unique solution to the equations describing Einstein's theory of general relativity that connects two distant points in space or time via a tunnel. That's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing video from us.